Okay, so continuing our exploration of problem 5, 5b, find an expression for the time t that passes between Mr. Rose's rock hitting the ground and Dr. Smith's rock hitting the ground. So, the equation that applies here, you were trying to find time here, so the equation that applies here is your displacement, I'm going to go ahead and write it as delta y, is going to equal your initial velocity. Sorry, I didn't mean to get that little hook on the v. Let me try it again. It's going to equal your initial velocity times the time that passes, okay, plus 1/2 times the acceleration times t squared, okay? I think we're all familiar with that. And what you will do then is, for each of them, you will substitute the appropriate initial conditions. So for Rose's rock, delta y is going to be negative h. You substitute the appropriate values. Initial velocity is negative v naught, and acceleration is negative g. For Smith's rock, same delta y, vi is positive v naught, and, well, yeah, same acceleration. And what you can do then is you can solve for a t sub s, which would be time for Smith, and a t sub r, which would be time for Rose. Find the difference between the two, and then you subtract the two. The thing is that these are quadratic. This is a quadratic equation, so you're going to end up having to use the quadratic formula. You get, square roots and something plus square root of something over something else, all that nasty stuff. When you simplify it, it actually simplifies down to something very nice, but it is a tremendous pain in the ass to do that. Okay, so what I'm going to do is show you the other way to do it, and this is what we call the elegant way. Okay, now the thing to observe here is that say Mr. Rose throws his rock down, and that takes some amount of time, which we are going to call t sub r. So that is the time for Rose's rock to come down. Smith's rock takes t sub, well, we'll call it t sub s time total, but what really happens is Smith's rock, well, let me hold on, sorry, my mind is sort of racing ahead here. Sorry, Smith's rock takes some amount of time, I'm going to call that ts1, to go up and then come back down. So this arc here that gets it back to the initial height of h takes some amount of time, and then it takes some amount of time to go down there. This is just like the way we sort of figured out that velocity would be the same with impact. Now, what is interesting here is that since Rose's rock starts with this velocity of negative v naught, and Smith's rock starts the second part of its thing with a velocity of negative v naught, TR and TS2 will be the same, right? So TR equals TS2, okay? And TS2 is the time for this second part of Smith's. So if you want to find this time that passes between the two, so that's going to be the longer one, which is Smith's time, minus the shorter one, Rose's time, okay? But Smith's time is made up of TS1 plus TS2, okay, so these two, and then minus TR. But remember, we showed that TR and TS2 are the same, right? So what happens, in fact, is these two cancel out. And what you're left with there is that the time between when these two hit, remember this is what we're solving for, right, is just equal to the time it takes Smith's rock to go shoop like that. So once you've gotten that, that's very easy. Probably the simplest way to do it is to find the change in velocity for Smith's rock between here and here, and that's going to be the final velocity, negative v naught, minus the initial velocity, which was positive v naught, right? So change in velocity was negative 2 v naught, and then we can use our old acceleration formula. If we have constant acceleration, you take delta v over delta t, okay? And so in this case, delta v is this negative 2 v naught. Delta t is just that t we're trying to find, this ts1, okay? So that's just I'm going to call that t, and that is going to equal, so I'm kind of doing this strange, but this equals this, and then I'm going to bring the a and put over here, but the a is equal to negative g, right? So this gives you the time is equal to 2v0 over g, and that is the time between when this thing hits and this thing hits. Now, as I said, if you did it with the quadratic and found the amount of time that tr took and the total amount of time for ts and subtracted them, you would eventually be able to simplify your result to this. But it would be an incredible pain in the ass. It would take a long time, a lot of ink. If you want to go through and do it that way, you can do it. I recommend going to the bathroom first because you're not going to want to be interrupted. And you will eventually get down to this if you do it right. Long and annoying. This way, you sort of leap quickly to the answer. If you wanted to, do this, I've written more than is necessary here, clearly. If you wanted to give this answer on a test, I would say write, a sentence or two sentences explaining your reasoning, and then say, therefore the time is just this. And I had someone who did that, 2 years ago on this test, when this problem was on the test, and they explained it that way. They wrote a couple sentences and wrote this, and they were correct because it was correct logic. They were thinking about the problem, and there you go. So I hope that helps everyone, and we will move on to problem 6 soon.